Hello everyone. So today we'll be solving 9709 paper 32 October November 2023. So let's start. Question number 1. Sketch the graph of y is equals to modulus of 4x minus 2. So to do these kinds of, we're simply going to make a table. X values and y values. It's recommended to take at least like 3 values. Two values are very important, where x is equals to 0 and one value where y is equals to 0, and the third value can be any value. Let's suppose that x is equals to 1. So firstly, when x is equals to 0, y is equals to modulus of 4 into 0 minus 2, which is y is equals to modulus of minus 2, which is equals to 2. Second value where y is equals to 0, so x is modulus of 4x minus 2. So 4x minus 2 is equals to 0. 4x is equals to 2. X is equals to 2 upon 4, which is equals to 1 upon 2. And the third value where x is equals to 1, so y is equals to under root of 4 into 1 minus 2. So 4 1s are 4, 4 minus 2 is 2. Y is equals to under root of 2, which is basically just 2. So over here, y is 2 when x is equals to 0. And then when y is equals to 0, x is 1 upon 2. When x is equals to 1, y is 2. Now we have to make a sketch that is recognizable, which means that it has to be very clear and symmetrical also. Now we can see over here that y is equals to modulus of 4x minus 2. Now this modulus is on the whole function. That means that every y value is going to be positive. It means the whole curve is going to be above the whole graph is going to be above the x-axis. So one point is x is 0 and y is 2. So 0 comma 2 is somewhere going to be over here, right? And then the second point is half comma 0. So x is half and y is 0. So x is 0 and y is 2. So let's say it's somewhere over here. And then the second point is half comma 0. So let's say x is half and y is 0. It's somewhere over here. And then the third point is 1 comma 2. So it's going to be 1. And then at the same point over here, 1 comma 2. So the sketch is going to be, we'll draw it with a scale. And it has to pass through these points. When we draw it with a scale, the line has to pass through these points. And this is a sketch. Part B. Solve the inequality. 1 plus 3x is less than modulus of 4x minus 2. So this is the case 2 of the modulus equations, like inequalities. So since this is case 2, it's going to be 1 plus 3x is less than 4x minus 2. And the second one will be 1 plus 3x whole multiplied by minus is greater than 4x minus 2. Because modulus basically means that the other thing on the inequality sign will be multiplied by plus and minus. So when this expression will be multiplied by minus, the sign of inequality will also. So let's start with this one first. It will be 1 plus 2 is less than 4x minus 3x. So 3 is less than x. Now on to this one. Minus 1 minus 3x is greater than 4x minus 2. So minus 1 plus 2 is greater than 4x plus 3x. So 1 is greater than x. 7x, sorry. And then 1 upon 7 is greater than x. Since this is case 2, we have to check the validity of the roots. So how can we check that? We are going to consider this inequality as an equation first. And then we're going to put these critical values of x into the equation and see whether both sides are equal or not. So first let's put x is equals to 3 value, like 3 is less than x. So 1 plus 3 into 3 is equals to modulus of 4 into 3 minus 2. 1 plus 9 is equals to modulus of 12 minus 2. And then 10 is equals to modulus of 10. So left hand side is equals to the right hand side. That means that this root where 3 is less than x is valid. Now on to this one. So 1 plus 3 into 1 upon 7 is equals to modulus of 4 into 1 upon 7 minus 2. So this side becomes 10 upon 7 and this becomes modulus of negative 10 upon 7. And since there is this modulus sign, modulus basically makes every negative thing positive. So 10 upon 7 is equals to 10 upon 7. So that means that left hand side is equals to right hand side. This root is also valid. So 3 is less than x and 1 upon 7 is greater than x. We can also write it as that x is greater than 3 and it is less than 1 upon 7. So this is the final answer of question number 1 part B. Moving on to question number 2. The parametric equations of a curve are this and this for t is greater than 0. Find the gradient of the curve at the point where t is equals to e, simplifying your answer. So we have these parametric equations and we have to find the gradient. So x is equals to ln t whole squared. So this is basically like the chain rule that dx upon dt will be equals to 2 into ln t raised to power 1 multiplied by the gradient of multiplied by the differential of ln t, which will be 1 upon t. And then when we solve it, it is 2 upon t ln t raised to power 1. So it's just ln t. And now y is equals to e raised to power 2 minus t squared. So dy upon dt will be equal to, this is the exponential, so this will remain same, that e raised to power 2 minus t squared, and it will be multiplied by the differential of 2 minus t squared. So the differential of 2 minus t squared is minus 2t. So we have over here minus 2t e raised to power 2 minus t squared. Now when we have to find dy by dx, that basically means dy upon dt multiplied by dt upon dx. So dy upon dt is minus 2t e raised to power 2 minus t squared, and dt upon dx is basically the reciprocal of this. So it's basically 2 upon t upon 2 ln t. So this is basically minus 2t square e raised to power 2 minus t square divided by 2 ln t. And now we have to find the gradient where t is equals to e. So dy by dx where t is equals to e. So this is minus 2 e square minus e square divided by 2 ln. So this is, we can cancel this 2 with this 2, and ln e is basically just 1. So we have minus e squared e raised to power 2 minus e squared, and ln e is just 1. And now we know, since the bases are same, we can use the law of indices and see over here that the bases are same over here. So, and they're being multiplied. So it means that the powers are going to be added. So this is e raised to power 2 plus 2 minus e squared. So this is equals to e raised to power 4 minus e squared. And this is the final answer of question number 2. Moving on to question number 3. The polynomial 2x cubed plus ax squared minus 11x plus b is denoted by px. It is given that px is divisible by 2x minus 1, and that when px is divided by x plus 1, the remainder is 12. And we have to find the values of a and b. So if we try to analyze the first piece of information that they gave us, that px is divisible by 2x minus 1, whenever they say that polynomial is divisible by something, this divisible means that it's a factor. So 2x minus 1 is a factor of this polynomial, so we are going to use the factor theorem. So we're going to equate 2x minus 1 to 0, and then 2x is equals to 1, and then x is equals to half. So basically, when we put the value x is equals to half in the polynomial will b equal to 0. And now the second piece of information, which is x plus 1, so we will use the remainder theorem. X plus 1 is equals to 0, and then x minus 1. So basically when we put x is equals to minus 1 in the polynomial, the answer of the polynomial will be equal to 12. So let's do that. First let's put x, let's put half instead of x. So the polynomial is 2x cubed plus ax square minus 11x plus b. Now 2 into half cubed plus a into half squared minus 11 into half plus b is equals to 0. Now this is 1 upon 4 plus 1 upon 4a minus 11 upon 2 plus b is equals to 0. So 1 upon 4a plus b is equals to, we'll take the numbers to the other side, so this will become 11 upon 2 minus 1 upon 4, and then 1 upon 4a plus b is equals to 21 upon 4. This is our first equation. So this is our first equation. Second equation, we will put minus 1 instead of x. So 2 into minus 1 cubed plus a into minus 1 squared minus 11 into minus 1 plus b is equals to 12. Minus 2 plus a plus 11 plus b is equals to 12. So a plus b is equals to 12 minus 11 plus 2. So a plus b is equals to 3. From here we'll make either a the subject or b the subject. So let's make a the subject. A is equals to 3 minus b. This is our second equation. Now I'm going to substitute this second equation into this first equation. So substituting 2 in 1. So a is equals to 3 minus b. 1 upon 4 into 3 minus b plus b is equals to 21 upon 4. So this is 3 upon 4 minus 1 upon 4b plus b is equals to 21 upon 4. Let's continue here. So minus 1 upon 4b plus b gives us 3 upon 4b, and I'll take this 3 upon 4 to the other side. So this will be equals to 21 upon 4 minus 3 upon 4. And then this will become 3 upon 4b is equals to 9 upon 2. So b is equals to 9 upon 2 whole divided by 3 upon 4. And the final answer is 6. b is equals to 6. b is equals to 6. And now we said that a is equals to 3 minus b. So a is equals to 3 minus 6 and a is equals to minus 3. So final answer that a is equals to minus 3 and b is equals to 6. These are the final answers of question number 3. Moving on to question number 4. On a sketch of an Argand diagram, shade the region whose points represent complex number z satisfying the inequalities this. So these are the two inequalities that have been given to us. Firstly, if we look at this inequality, its modulus of z minus 4 minus 3i is less than or equal to 2. So in this case, firstly we have to take minus sign common over here, so it would become 4 plus 3i is less than or equal to 2, and this will remain said that real part of z is less than or equal to 3. Now we're going to make our Argand diagram. So if we look from here, we see that 4 plus 3i and then there's 3. So this will be our imaginary axis. This will be our real axis. 1, 2, 3, 4, 5, 6. And then we have 1, 2, 3, 4, 5, and 6. Right? So if you look at this inequality first, so it's basically going to be a circle and the center will be 4 plus 3i, the radius will be 2. So 4 plus 3i is somewhere over here, right? Now I'm gonna add a circle over here. Here's our circle, right? So basically this this point will come till 2, this point will go till 6, right? So this is our circle. And according to this inequality, point Z basically lies within the circle or on the circumference of the circle, right? We're not going to shade it right now. And then they said that the real part of Z is less than or equal to 3. So real part means on the x-axis, and it's less than or equal to 3. So this is our line, right? We're basically going to make a line over here. This is our line. Real part is less than or equal to 3. Now we're going to shade it. So according to the first inequality, the point Z is going to be either inside the circle or on the circumference of the circle. Now according to the second equality, real part of Z is less than or equal to 3. So less than 3 means it's going to be here. So this is our shaded region. And then we're just gonna, this is our shaded region. This is the answer to part A. Now part B. Find the greatest value of argument of Z for points in this region. Now to solve this kind of question, you can't just simply put a protector. So argument of Z basically means that argument of Z minus 0, right? So which is a point like, right? So basically means argument of Z minus 0. Now the argument of Z should be such that it should have the greatest value. Now remember that Z basically lies in this region, either on the circumference or in this part only. So where should Z lie so that it has the highest angle or the greatest angle? So Z minus 0 means that it will start from 0. Let's suppose if Z is over here, and if you make a line like this, so this is the angle that's making, which is basically the smallest angle, right? Now if we try like saying if this is Z, and then if we make an angle, so this is the angle that we're getting, okay, it's bigger than the previous angle. Now if I try basically somewhere over here maybe, and if I try to draw a line, so this angle is even bigger. Now if I try to go beyond this point, let's suppose if I say this point, right? So it's basically gonna like cut through this circle, and this will be the line. Like this will be the line for this point. So it will have a shorter angle. So this means for Z to have the highest angle, it must lie over here somewhere, right? So this is the angle that we have to find with the positive x-axis. Now how do we find it? The most common way is that we try to make a right angled triangle or something, right? If I make a line through the center of the circle, if I try to make a line through the center of the circle, it's gonna be this, right? And then if I join this point here, which is basically 4 as we know, so this is one right angle triangle that we have. So we can find this angle. But now what about this angle? How do we find this angle? So if I take this line and if I join it over here with this, let me change the color. So this is our line over here. Do you know that radius and tangent make 90 degrees with each other? So this is our radius in red pen, and this is our tangent in blue line, and this is 90 degrees. So again, this is one right angle triangle, and this is another right angle triangle. Now we can just find, and then we can just find this angle, then we can find this angle, and then we can add them together. So firstly, let's say that this point is B, right? This point is B, and this point is O. So this line becomes OB, because now to find this point we need at least 2 of the lengths, right? So we have this length which is 4, right? The base is 4. So now we either need the perpendicular or we either need the hypotenuse, and we can find the hypotenuse because we know the coordinates. That the coordinates of O is going to be 0, 0, and the coordinates of B are 4, 3. So firstly we find the length of OB. The formula for length is x2 minus x1 whole square plus y2 minus y1 whole square. So let's suppose this is x1 y1, this is x2 y2. So x2 minus x1 becomes 4 minus 0 whole squared plus y2 minus y1 becomes 3 minus 0 whole squared. So this is square root of 4 squared plus 3 squared. So this is square root of 16 plus 9, which is under root of 25, which is 5. So OB is 5, right? Now we can use trigonometric ratio to find this angle. So over here we will be able to use cos theta is equals to base upon hypotenuse. Cos theta is equals to base is 4 and the hypotenuse is 5. So theta is cos inverse of 5. I'm keeping it in this form so that it's exact. And now to find the second angle, we have another right angle triangle, which is this, and we already know the length of OB is 5 and this is the radius, which is 2. So in this case is the perpendicular, that's 2. So now we can use the sine trigonometric ratio, that sine theta is equals to perpendicular over hypotenuse. So sine theta is 2 upon 5. Theta is equals to sine inverse of 2 upon 5. Now to find the final angle, it is gonna be cos inverse of 4 upon 5 plus sine inverse of 2 upon 5. So we're gonna find the angle in radians, and the answer is 1.06, correct to 2 decimal places. And this is the final answers in radians. And that's it for part B of question number 4. Moving on to question number 5. Find the exact value of this. The integral of x into x plus 1 divided by x squared plus 4 with respect to x. So if you see, I'm just going to copy it first. So x into x plus 1 divided by x squared plus 4 with respect to x within the limits 6 and 0. If you look at it, we can see that this is a kind of partial fractions, right? So first we're going to simplify this using partial fractions and then we're going to integrate it. So x into x plus 1 divided by x squared plus 4. So we can see that this is basically improper fraction because the degree of x is 2 in the numerator and in the denominator as well. So we will write it as a plus bx plus c upon x squared plus 4. So this is the way to write it in partial fractions. And now we're going to multiply both sides. We're going to multiply both sides by x squared plus 4. So this becomes x into x plus 1 is equals to a into x squared plus 4 plus bx plus c. We can take, so firstly, to find the value of a, what do we do? Since this is improper fraction, to find the value of a, we divide the coefficient. In this case, it's basically the x squared, right? So we divide the coefficients of the highest degrees together. In this case, the coefficient of x squared in the numerator is, so a is equals to the coefficient of x squared. In this case, the highest degree of x is 2, basically means x square, right? So we are going to divide the coefficients of x square in both numerator and denominator to get the value of a. So the coefficient of x square in the numerator is 1, like if we multiply these x together it will be just 1, right? Divided by, in the denominator also it's 1, so a is equals to 1. And then we can equate x is equals to 0. So this whole thing will become 0, and over here it will be 1 into 0 square plus 4 plus b into 0 plus c. So 0 is equals to 1, 0 square plus 4 is just 4, so 1 into 4 is 4 plus c. So c is equals to minus 4, and then we can take any value of x. Let's take x is equals to, c is equals to minus 4. And now let's so we can see that this is a sort of partial fraction. So we're going to solve it through partial fractions. x into x plus 1 divided by x squared plus 4. We can see this is an improper fraction because it's x square in the top in the numerator and x square in the denominator. It's going to be a plus bx plus c upon x square plus 4. So firstly, to find, and now we're going to multiply both sides by x square plus 4. So this becomes x into x plus 1 is equals to a into x square plus 4 plus bx plus. Now to find the value of a, what do we do? In this case, the highest degree x is of the power 2, basically means x squared. So to find a, we divide the coefficients of the highest degree. In this case, it's x squared, right? And it's an improper fraction. So we see in the numerator, when we multiply these x together, it's x squared. And what's the coefficient? The coefficient is 1. And the denominator, again, it's x squared and the coefficient is 1. So a is equals to 1. We just divide the coefficients of the highest power to find the value of a in improper fraction. And basically the power is going to be same, right? And now let's take any value of x. Let's say if we take x is equals to 0, we can omit this b from the equation, right? So we take x is equals to 0, and then we have 0 into 0 plus 1 is equals to 1 into 0 square plus 4 plus b into 0 plus c. So this becomes 0 is equals to 4 plus c, and c is equals to minus 4. Now we can take any value of x. Let's take x is equals to 1. So it's 1 into 1 plus 1 is equals to 1 into 1 square plus 4 plus b into 1, and c is equals to minus. So 1 plus 1 is 2, 2 into 1 is 2 is equals to 1 square is 1, 1 plus 4 is 5, 5 into 1 is 5 plus b minus 4. 2 is equals to 1 plus b. 2 minus 1 equal b. So b is equals to 1. And if I write it as the partial fraction form, so x into x plus 1 divided by x squared plus 4 is equals to 1 plus x minus 4 upon x squared plus 4. A is 1, and then I wrote bx plus c. B is 1 and c is minus 4. So this is the fraction form. And now this basically becomes that integration of 1 with respect to x within the limits 6 and 0 plus the integration of x minus 4 divided by x squared plus 4 with respect to x within the limits 6 and 0. And now see, when we integrate 1, this basically becomes x. So x within the limit 6 and 0. Now I'm going to separate this fraction further, that it becomes plus integration of x upon x squared plus 4 with respect to x within the limit 6 and 0 minus integration of minus 4 I take outside because that's a constant, and then 1, it's just 1 inside, divided by x squared plus 4 with respect to x within the limit 6 and 0. So we'll solve this term later. Let's see these terms one by one. If I see this integration of x upon x squared plus 4 back to x within the limit 6 and 0. So if I try to remember some kind of rule that I learned in integration, I can't really see it. I have to basically change it in some way. If we see that f dash of x upon f of x, if you see this this term, which is x squared plus 4, the differential will be 2x, right? But over here we just have x. If I want to add 2 over here, I will just multiply this term with half, so that this 2 and this 2 gets cancelled, and there's no overall change, right? So basically I'm going to do this. I add 2 over here and I multiply it by half so that there's no overall change. And now it becomes of the form f dash of x upon f of x. It becomes of the form f dash of x upon f of x. So I can simply use the law now, which is half ln x squared plus 4 is modulus within the limits 6 and 0. And now if I look at this term, minus 4 multiplied by the integral of 1 upon x squared plus 4 with respect to x within the limit 6 and 0. So it's just 1 upon x squared plus a squared, right? So this term is of the form 1 upon x squared plus a squared, where a in this case is 2. Remember, it's not 4 because 2 squared is 4, right? So the integral is that this minus 4 will be multiplied by this 1 upon 2 multiplied by tan inverse of x upon 2 within the limits of 6 and 0. Simplified further, 2 ones are 2 and 2 twos are 4. So minus 2 tan inverse of x upon 2 within the limits 6 and. So now what I can do is that I can combine all of them together. That 1 plus this plus half ln squared plus 4 minus 2 tan inverse of x upon 2 within the limits 6 and 0. So first I put 6 in all of these x's and then I subtract it from the. So now I put 6 in instead of x. 6 plus half ln 6 squared plus 4 minus 2 tan inverse of 6 upon 2. Right, this whole thing will be subtracted from where x is equals to 0. So 0 plus half ln 0 squared plus 4 minus 2 tan inverse of 0 upon 2. Now we have to be very careful in these steps because it is very much possible that we might make any kind of silly error like a sign mistake or copying a number incorrectly or anything, right? So let's see. This becomes 6 plus ln 40 raised to power half minus 2 tan inverse of 3 minus ln 4 raised to power half. So I combine the ln together, which is basically 6 minus 2 tan inverse of 3 and then plus ln 40 raised to power half and 4 raised to power half, right? We can take the power common in ln, so 6 minus 2 tan inverse of 3 plus ln 40 upon 4 raised to power half. So that's 6 minus 2 tan inverse of 3 plus ln 10. 4 ones are 4, 4 times 40, ln 10 raised to power half. Okay, and this is the final answer of question number 5. It's 6 minus 2 tan inverse of 3 plus ln 10 raised to power